Switching the program. Now, things are a little squeezed on here as far as the program is concerned.
Switching the program.
Now,
Things are a little squeezed on here as far as the program is concerned, but the chemical up here is acetone. This is a calculated infrared spectrum for acetone, because then it works with the program. It's linked to Spartan to try to show you some of that stretching and bending as far as actual molecules
So
go.
notice,
And then we'll talk a little bit about interpreting actual infrared spectrums. So notice on the calculated spectrum there are a few peaks.
Just a tidbit about
the exact numbers are not quite right. And that's an interesting thing. And just a tidbit about what the people at Wave Function do as they're developing this program, the software. They know that the calculations give a consistent error of, I think, a little less than 10% when it comes to calculating the numbers of the infrared spectrum. But the problem isn't in the software per se, it's in the algorithm that tries to convert molecular mechanics into spectral data. And so they're trying to figure out exactly what needs to be done properly rather than just adding in a fudge factor to make it look right. So the numbers are a little off on the spectrum compared to the real spectrum.
We don't really know yet.
But again, that's for quantum mechanical reasons and how much we don't really know yet and are still working on. Now this peak here is due to the carbonyl stretch. And so if I click on the peak, you see that, right? So that's oxygen, that's the carbon of the C double bond O, and that's that stretching motion. So the two atoms in real time, in real space, are moving back and forth relative to each other. Now, it is more complicated in a real molecule because notice that as a consequence of this carbon atom moving, these bonds are all.
I don't want to
so there's
get too caught up in the really big.
And I don't want to get too caught up in the real big picture. As far as
to show you
every little detail
a few other
about what
things.
happened.
Then these peaks over here are responsible to CHs, those bonds, and so.
These peaks over here are responsible to CHs, those bonds, and so,
which kind of stretch?
if I rotate
Can you recognize it? Remember, two types of stretch, asymmetric and symmetric.
You recognize it?
Asymmetric.
Remember, types of stretch, asymmetric and symmetric.
Those two hydrogens are doing
This one's asymmetric.
One's coming in while the other's
Because
going out.
on this particular carbon, those hydrogens are doing the opposite. One's
And
okay.
clicking on a different peak here, that just gets a different set going, right? So because they're methyls and they have three hydrogens,
that just gets a different set going, right?
When it comes
So
to
because they're
combinations of
methyls and they have three hydrogens
which,
each,
which of the three hydrogens
when it comes to combinations of what can happen,
really
which of the three
to
hydrogens
get a
are doing
program
what?
like this and just ask
And it gets complicated to
what
really
might
think
happen.
about it.
And these peaks
It's
down
easier to
here
get a program
should
like this
offer
and
a
just
different
ask it
bending. Yes.
what might happen.
Maybe.
And these peaks down here should offer a different bending.
Yeah, there you go.
Yes.
So
Maybe.
now what's happening? A lot of stuff is happening. Yeah, it gets
Rotate
kind
the
of funny.
molecule back a little. Yeah, there you go.
Well, you should see a really.
So now what's happening? A lot of stuff is happening. Yeah, it gets kind of funny
yeah.
too after a while.
That carbon's
Well, you
moving
should see a really
sideways
complicated
relative to
molecule, all
other
the
two
stuff it
carbons, so it's a type of bending.
But yeah,
It's a type of rock.
that carbon's moving sideways relative to the other two
Anyway,
carbons, so it's a
just
type
wanted to
of
show you
bending.
that so you have
It's a type
some
of
idea of
rocking.
what a molecule is really
Actually.
doing.
So
Acetone's
anyway,
fairly
just
simple.
wanted to show you that
Also,
so
the
you have
strong
some idea of what a
dipole gives some good
molecule is really
absorbances
doing.
that allow us
Acetone's fairly
something to talk
simple.
about.
Also, the
Questions or
strong
anything?
dipole gives some good absorbances that allow us something to talk about. Questions or anything? Okay.